All right, hi everyone. We'll get back after the break. And this is actually a really cool part because we're going to talk about doing some triaging at scale. This is like a new feature that sort of came out this year and recently. And it's really more going beyond the forensics. We've seen before how we can do, forensics, try and find files, try and find what happened. And this is going the next step, like try and automate detection and try and figure out what bad happens. So this is the difference. So forensics, I would define forensics as trying to figure out what happened. You know, like what happened would be, user went to msn.com, they read the news, they then, went to Google, they searched for, whatever, and so that's what happened. So you're going to get that as part of user activity, and it's not really interesting most of the time, right? But you really want to know what bad happened, right? Which is user went to a watering hole, they downloaded some malware, and then it ran PowerShell. That's what we want to know. Right? So forensics is about trying to find what happened, but then detection is about trying to find what bad happened. So this is kind of my explanation. And you've seen that we have hundreds of artifacts, and actually that's a problem that we are getting in the project because we're encouraging people from the community to submit artifacts, and then there might be small artifacts that people say, hey, there is this, and remember I actually did say that initially when we talked about the VQL, is that there will be a detection, and you'll go and write a VQL artifact and share it with the community. And that's kind of the story, but we're now at this stage of the project where there's just so much of them. Like there's so many artifacts, and most of them are just tiny little things, like look at this registry key, look at this file, and try and detect based on these things. And so we're getting to the point now where we really want to, let me just go full screen here. We really want to try and automate a lot of this stuff. So from a user perspective, we can't just ask someone to collect 300 different things, right? Because it's just really hard to get them right. We want really big artifacts that just do like everything, right? Really automated, really, really easy to use. And so we're moving towards that world where we have these curated artifacts. And this is what I wanted to talk about today. So we have a number of examples here of these artifacts. So if you only take one thing away from this workshop is that now your job as investigators is even easier because you're just going to be collecting these 3 or 4 different ones, and you're already halfway through your job, right? Because they will give you all the leads you need. So these are the ones we're going to talk about today. The Sqlite Hunter, which automatically hunt and parse all browser or OS artifacts, mostly Sqlite files, but now also other files. Registry Hunter, Evtx, and Sigma. So we're going to go through them, as examples. So let's start off with the Sqlite Hunter, and you might already know that Sqlite is like a database format. And a lot of things use it, the Sqlite, right? So browsers use it, Macs use it heavily, Windows is starting to use it as well, a lot. So it just makes sense that we would just, look for Sqlite files. And we used to have lots of artifacts like Chrome history, and then Firefox history, and then Edge history. So these are different artifacts, and you're like, I just don't care, just give me all the history, right? So that basically is how we collect it all at once. So Sqlite is actually built in. So we're just going to search for Sqlite Hunter. There it is. And it's one of those Uber artifacts that's actually managed externally. And I've got the link here. Let's open that in a new tab. So this is another project that we sort of use all of those little queries. And the idea is to try and keep those queries like in another project so we manage them, but then bundle it all together into one artifact, so the user, you guys, just hit a button and they just get everything, right? So I don't want to have to choose, right? And so you can see here we have different definitions of the different, Sqlite files that we might want to look at. So the definitions are fairly straightforward. They have they have some select query to see, you know, whether the Sqlite file is the right one, and you know, and then some categories, and so we know there's some globes, so we know where to look for those files. So it's actually super automated. So like in this case, you know, we're saying, oh, Chromium browser media, where do I find those Sqlite files? So we have, okay, we're going to look for them in these different places, in the profiles and whatever, and it's going to be called this, and then we use that. So from a user perspective, all we have to do, let's configure this artifact. All we have to do is to basically nothing. You know, all is the default, so look for everything, all right? And I would also just upload the Sqlite files, just why not, right, to get the original files. But basically, yeah, just go, right? So super easy. And what this is going to do is, because it already knows where the Sqlite files are living on the system generally, so it will go and find them, and then parse them and extract the data. And so it will send the actual, because I asked it to send the actual file, so we've got the 30 megabytes so far. And then also all of these rows are coming back, because we are essentially dumping out all the tables, right? Different tables. And then we are enriching them and changing the, and adding information where needed and things like that, right? So in this case, let's have a look at the results on this machine. And again, this is a used machine that, you know, all kinds of crazy stuff, you know, happened on it. It's a dev machine, so it's been used for a couple of months now. But these are all the different artifact sources, remember I mentioned before, and we've got essentially every rule that triggered that found the Sqlite file is in there. So let's look at, for instance, like in this case, I think it's history visits. So that shows us like where, you know, the URLs, you know, this user had gone to. So this is an example. I want to show you this really cool trick here where we can do stacking. We're going to talk about stacking a lot later, but this is also another example. So I've got all this data, and there's going to be, this is the whole browsing history of this user. Obviously, this is the same machines that we're using, so we're going to have local hosts. This is Velociraptor, but there's going to be other stuff. So there's like 9,000 different rows here. So I'll show you how to do some post-processing. So I'm going to hit the notebook, okay, and straight away, okay, so this particular notebook is split them up by different sizes, but look, you know, I'll just, let me just delete that one, I'm not interested. And, you know, each different one, the browser extensions and so on. I'm just going to look at the history visits, this one. Okay, so here's the history visits. Where was it? Here, this one. Yeah, I'll move it to the top. Actually, you know what? I'm going to copy it to my analysis one, because I want to analyze it, right? So I'm going to copy it to my analysis one, like I did before. Okay, go there, and now I can already process it there. So let's do that. So this is my analysis one. I'm going to show you. This is a dodgy user, let's say. Now you see how it's in this UI. It's kind of a bit hard to use because you've got the top, pane and the bottom pane. So I'm going to click on this thing and just go full screen because like it's just easier. So now, you know, it looks more like a flowing document, right? And now I'm going to edit this VQL so I can post-process it. Now you see it's got a lot of different columns, lots of columns, and I don't really care about these columns, too many, and I don't care. So I'm going to just show a few of these columns. So I want to know about the visit time, let's say, and I want to know the URL title. So I've got this completion that's basically telling me, you know, all the columns in this table, so I can just do it, and then the URL, right? So that's the actual URL, but I'm actually more interested in like what sites the user went to, because, you know, and you can see here when I go to a particular site, there might be like hundreds of URLs, but they're all like on the same server, so they're kind of like the same, right? They're just different parts of the application. So I'm not really interested in that. So what I want to do is I want to parse that URL out, right? So I'm going to parse it into the different components of the URL, and I'm going to just look at the host name or the host part as host. Host. So that's just like the host part of the URL. So let's see how that goes. Okay, so you can see that now. So like, it just extracts that one part out of the URL. And now I'm going to show you stacking. So before I show you that, let me just move that to the top. Yep. And stacking. Okay, so over here, first of all, I'll remove that limit 50. So by default, it only shows like 50 rows just to give us a view of like what data is there, but I'm just going to do all the data. So there's, close to 9,000 different rows here. And I want to know what this user's been doing, right? So obviously for me to review 9,000 URLs is a lot, right? I'm not going to sit there and look at 9,000 things. But I can actually get a pretty good idea of what the user's doing by looking at the host name, right? So that part of the URL. So what I'm going to do is stacking. Stacking is a process where I can just combine common things to groups, basically groups, and then look at each group separately, and then I can inspect each group in detail. So I'll show you. So the first thing I do is I sort by host name. And so what that will do is it puts all the host names together, right? So here's all the YouTube, for example, right? And every time there is a YouTube, they're going to be one under the other, right? Because I sorted them, right? So then if I click on that stacking icon next to that, then it's going to basically count how many times the same host name appears together, right, in this sorted table. So the table's sorted, right, and then it's just basically just counting. Oh, YouTube appears, 14 times. So there's 14 different URLs, right? And then Ultimate Windows Security appears one time. Reddit, whatever, right? So all of this stuff is it's grouping them into groups. Right, so now I can immediately see there's like 66 groups, I can just go through them, whatever. And let's say W3 schools. Like I'm like, okay, what did that user exactly do on W3 schools? Right, maybe that was like a watering hole, whatever. So I click on this thing, and it takes me to that part of the table, right, where we're talking about W3 schools, right? So I can then see the details so that's called stacking, right? So I basically take all the data, combine it together on groups of common things, then I look at each group separately, right? Because that allows me to eliminate the boring stuff really quickly. But because it's built into the UI, you can do it on anything, any column, anywhere, right? Because it's just part of the UI, right? So you can do the stacking without even really writing queries or anything. You don't need to PQL to do the stacking anymore. You used to have to, but it's a new feature. So you can see how now we just ran the Sqlite file, well, like the Sqlite hunter, and we're like, okay, where did the user go? Quickly review it, and then look, there's some dodgy sites. If you guys have done the thing yesterday with the tutorial with the malware, fast flux DNS names, you can usually look at them and go, that's a dodgy site, right? Because it's a phishing site. The DNS names are fishy. So you can immediately identify, hey, maybe that's a watering hole, and lock on that really quickly. So that's an example of using these Uber artifacts to do these very SQLite hunter. There's other cool stuff in the SQL. Let me just get out of full screen mode here. Let me just, you can also open another tab. Normally I have lots of tabs open. So if we look at some of the other cool results from Sqlite Hunter, it actually does things that are not just SQLite. It started off with SQLite, but there's other things here. For example, the Windows Search Index. Windows Search Index is useful because it tells us about different files that it searched, right? And the search. So even if the file's deleted, then we've got evidence in the search index that these files were searched. So they were there, right? And then we have timestamps and things like that. So in a lot of forensic cases, we are like, was this file, did the file exist? Did they copy the IP onto their, directory, staging directory, whatever, like these kind of questions. So the search index is actually a really, really good, source of information, but it's not SQLite, it's ESC, so it's a slightly different format, but, we just put it all in the same artifact because why not? It's easy, right? So the same kind of thing, you can find like evidence of different files and that kind of thing. So there's a whole lot of forensic blogs about, how to interpret these kind of, information. So that's really useful. But anyway, the takeaway from this is you just have this like one Uber artifact, you just kind of like throw it at the thing, it does the thing, it just gets all the data, parses it, analyzes it, dissects it, and very quickly, and then you can just filter it afterwards or whatever. Yeah, so this slide just talks about the general format of the Sqlite Hunter rules format, and we talk about the results. So that's cool. Do you guys have any comments about Sqlite Hunter? Questions? No? Okay, cool. So the next one I wanted to show you is the Registry Hunter, and this is about doing the same thing like the Sqlite Hunter, but with Registry. And the Registry, as you know, is really where we look at a lot of information forensically. Was this program installed? These kind of things. And so we need an automated way to look at all the keys and values in the registry because there's just so many. So what we wanted to do here is create a similar thing, like inspired by the Sqlite Hunter doing the same thing for the registry. It's just one great big artifact that does all registry things together very quickly. So that's the Registry Hunter, and again we've got we actually have a little website for it here that with a little blog post you guys can read about it and how it works. But anyway, you don't really need to figure out, you don't really need to know anything about it other than how to import it. So like the artifact exchange, it's managed in its own different repository. So we need to import it to get the latest. We also wanted to do it so that it has a different release cycle from Velociraptor, so we can change these rules really quickly. So we can add rules all the time. So it's always worthwhile also importing. It's just a different zip file. So the same thing you can do it manually, like I showed you with the exchange. But all it does is it just does this one artifact, just this one, the Registry Hunter. So let's collect that. I'll show you how to do that. Collected. Okay, Registry Hunter. You can just do like this. Hunter. Oops. Registry Hunter. So again, it's a very complex artifact. This is one of the very complex VQL artifacts. They're actually maintaining their own repository, but you don't need to worry about it as a user. You just need to kind of say, yeah, just do it. So there's a lot of different categories. There's rules, a lot of different rules. We'll see them in a minute, but a lot of different rules about basically this key and what does it mean. The main problem with registry analysis is that, first of all, you have lots of keys, so you need to know which one you're looking at and why. You need some semantic context. What does this key mean? If I have this value, what does it mean? If this value is 1, what does it actually mean to me? Right? So that semantic context, that's the main thing. And then also a lot of the time the rules, the values in the registry, you need to interpret them and parse them somehow. Sometimes it's obvious, sometimes it's not obvious. Because at the end of the day, the registry is not really meant for human consumption. It's for the software, right? So if, a lot of the time the key might say, yeah, it's 1, so that means true. Or 0 means false. Okay, that's easy. But what about, when it has like a binary blob in there? what does that mean? Or if it has like a timestamp, what does that mean? So all of these rules are actually part of Registry Hunter, and we try and parse them and extract that information out. So these are all in the categories. So yeah, most of the time we just we can click this button here, which just also collects the raw hives. But let's just go and let's just collect them and see what happens. Okay, and it normally doesn't take very long. But if we look at the results, so you see that we collected the hives as well. But the results basically, it's a rule-based artifact, and just look at this artifact, the results here, and you can see that we have the same thing. Category, this is the rule description. It's looking at a particular key, that it's looking at, and then it interprets it, and we have these details tab that just basically fills in information about this tab. So let's say, how would you use something like that? So let's say I'm going to go into the notebook, okay, and look at all the results. And let's say that I wanted to know anything about the user. Oh, let's say that I wanted to know if PSExec was run on this machine, like anything to do with PSExec. So what I would do is so this gives me all kinds of information, right? System info or user info, whatever, right? But I don't really want to look at all that stuff, because when I'm in DFIR mode, again, the difference between it is forensics is telling me everything that happened, but I don't care about everything that happened. I just care about what bad happened. So let's say I just do a where, and in the details, so this part here, details, I'm just going to go details, like somehow mentions, PSExec. Okay, like something like that, right? So I'm just interested to know if PSExec happened here. So when I run this, then straight away I will see that it's going to filter out different rules on the registry. So what registry evidence do I have that that indicates PSExec was run? So I have this rule, which triggers on. So this rule actually is a EULA rule, so it triggers on, when you run PSExec, it says the EULA, right? So that is stored in the registry because you accepted the EULA, right? So that means that that's the first run time when you ever ran PSExec. So if you're on a developer machine, they run it all the time, so probably it doesn't mean much. But if you're on a secretary machine or a finance person or a legal person or whatever, they're not going to run PSExec, right? So if you see that key on their machine, that's a red flag. Something happened here, right? Because they're not going to ever need to run this, right? So that's a problem. So we have this. So that's that rule, and then we have other rules. Oh look, this is user assist. User assist looks at a different part of the registry. This is a GUI-based program launched from the desktop. Someone clicked on it from the desktop, okay? And so it's a different key, and you can see that the key is actually obfuscated here. It's a ROT13. You don't need to know the details because, we extracted that in the Registry Hunter, right? It unrotated it, whatever. It's not encrypted really, but, And so we can see that somebody clicked on it from the VMware. As I said, it's a developer machine, so all kinds of interesting stuff happens, right? And so we have, more of this user assist stuff, more sysinternal, and then we have this other thing. This is app compat cache. It's another part of the registry that deals with something else. So there's a shim cache, right? Data is only written to this value at reboot. So again, another thing. And we've got, something. A signature, evidence, and another timestamp. So you see, what I'm doing here is I have this registry analysis, and it just analyzes all these things based on rules, and then I can basically narrow it down and say, are any of these relevant for my investigation? And so typically, like an investigation like that would be sometimes a user account is is compromised, and then they use that to laterally move across the network, right? So I could say, tell me all the things about the registry that have this user account in it, and then I will get like log on keys. I'll get install keys, profiles installed, because when the user is logged into a machine, the profile gets copied, so I'll have the profile timestamps. Basically anything to do with that user actually exists on this machine, right? So I end up with lots and lots of information. So that's the idea, is to just have like this Uber artifact. I'm just going to set it and fire it and do it. And of course I can always look at the details, but I don't want to spend time doing that. I don't want to look at it. This is the problem with forensics in general, is there's so much information that the trap is that you end up, just getting lost in the data and just spending a long time just reading or reviewing logs without any plan. You have to plan, what exactly am I doing this for? Why do I do it, right? So that you can, use your time more effectively. Anyway, so this is a Registry Hunter, very cool new thing. Again, one of the first things you'd run and just do it, right? And getting the results. This is what we went through. You can do stacking as well. We can do stacking on this one too. This is an example of, but I already showed stacking, so I'm not going to do it again. And we can examine the hits and so on. Okay. Oh, and then this is okay. So I did a slightly different examples, but okay. Details Velociraptor. This is the example that I had here. I mean, you get the point, right? Velociraptor. Yeah, there's going to be different things as well, like the same things as before, but there would be services and things like that as well in this one. Yeah, see there's anyway, and then we can do some more stacking and things like that. So yeah, with the stacking, you see that the same rule is triggering lots of things. So that's where the stacking really helps, because you see there's like 100 rows that are just this app compat cache, which is, it's interesting, but it's not super interesting. So when I do the stacking, I can just discard all of these rules that are triggering a lot and then just go for the ones that are interesting. I can just, at an overview, say, oh, okay, I can see there's a service installed because that's one of the services. It's in recent doc, it's on radar. So here's my services, and I can say, oh, the service was installed, get timestamps and things like that. So yeah, that's the example I had in the slides. Okay, cool. So that is the other artifacts that we would run straight away. The next one is the Evtx Hunter, and this is a super powerful artifact that we use a lot to just kind of like get an idea of it's kind of like going fishing. Like you just don't know what you're going to get, but it's always going to be good, right? Like, so we use it in cases where we don't exactly know what happened, but we know that it had something to do with like a particular keyword. For example, let's say that you have a user account that was compromised, right? So user account is compromised, and they use that to laterally move across the network. And the user account is, Fred Smith or whatever, right? So anytime any log anywhere mentions Fred Smith, I want to know about this because I know this account was compromised, right? But so if the traditional forensics approach is to say, well, okay, so we're going to look at RDP logs, we're going to look at login logs, we're going to look at, whatever, right? So there's a set of, common ones that we look for that mention user accounts, right? But what if I turn the question around and say, I just want to know anything to do with that guy, right? Like Fred Smith anywhere. So now I'm going to basically literally grab my logs for Fred Smith, right? It's a pretty unique name. If I see Fred Smith anywhere in the logs, I want to know about this. So you'll actually get information like Chrome installed a new profile. Like, and that only happens when the user logs in interactively and starts Chrome, right? Like, so obviously then you're like, hey, hang on a minute. That, that happened on this machine or whatever. So you basically get a lot of context that you just wouldn't get just by looking at login logs, right? So because you're actually working on it backwards. So this is Evtx hunter. So in this case, let's say we're going to, in this example, we're going to look for Evtx hunter, Evtx hunter. Here, yep. And basically, it's kind of one of those, it's like the file finder, it has lots of knobs. You can change different things, but most of the time, what I would do is I would just look for all the event logs, and I just do the IRC regex, and in this case, we're just going to look for Velociraptor. And you can tweak it and all this stuff, and time box it for sure, like if you would use it for real. But I'll just do this, and basically just let it rip. Let me just do that. It's going to take a little while because it's basically literally parsing every single event log. There we go. But in a short time, it should find something to do with Velociraptor on this system, and in the event logs, and we'll see what kind of information it can find, right? So it basically parses everything. Oh, look, it's found some stuff and found a lot of stuff, right? So let's take a quick look. And then recalculate the event log so we can get the freshest data. And so you can see here we have different channels. So this is the application channel and the provider. So this is the provider of the event log. So each event log, has a channel, a provider, and then the event message and the event ID, right? And what we've done here is we are just saying, just tell me all about anything that mentions the word Velociraptor. Cast a wide net, right? It's going to give us, look, 33,000 rows already, like lots of rows, right? So what we're going to do now is we're going to use stacking, the same thing that we did before, right? So let's do that. So first of all, I'm going to remove that limit 50 so we can get, the latest information. Oops. Okay, so that gives me all of the data, right? So let's do that. And I'm just gonna make it full screen because it's just a little easier. Okay, and now I'm going to sort it by, let's say, provider, right? Because I want to know what type of information. So the provider is like the program that made the log, right? So I want to know like what type of information this is going to give me. So I do this sort, right? And then I do the stack. So just like before, right? And so now I'm just going to look at an overview of what kind of providers mention the word Velociraptor in there. Like, I don't know. So we can see that there is a provider called Velociraptor. So that's the Velociraptor itself, right? Reporting itself, which is kind of obvious. But then we have the MSI installer, so it's installed. So we know the MSI installer is reporting something to do with Velociraptor. It's interesting. Sysmon is reporting a lot to do with Velociraptor because it's Sysmon. We have some security mitigations, which is actually like also kind of interesting. We have some PowerShell stuff, code integrity, and so on. So this is just as an example. We're like, hey, what does the SMB server have anything to do with Velociraptor? Let's see. So we'll just jump in there and take a quick look, and we can see, okay, file system operation took longer than needed. So even this is an example of like something that was completely unrelated. It's obviously it's using a SMB share, but it somehow didn't work or took too long. But now we have an evidence that this program ran and did something over SMB at this time. It's not really related. It's not one of those event logs that we would typically look for. So having this Evtx hunter just bring it up, that's actually really cool. This PowerShell is an interesting one. It's basically creating a script block. So here we have the event data, and you can see that it's running Velociraptor. We can actually just like remove some of these, clear all some columns because there's just too many. We want to bring that provider back and the event data maybe. Oh, no, not the username. Event data. Yeah, so this is just a bit cleaning up the columns, so it's a little bit easier. So we can see, okay, this is where we ran this command, right? So this is just like a command line invocation, and it's basically PowerShell script logging, so it's telling us that. So anyway, yeah, go ahead. Sorry.
Can you go back down really quick?
Yeah, sorry.
Can you stack by the partial information in the event tab? So can you stack by the script block text?
Right. So yeah. So if I wanted to do that, what I would do is I would say, okay, now I can write a VQL to say I'm going to just look at the rows that have provider is PowerShell, and I would split that up into a separate columns. I'll just do it now. Why not? So then, I would just basically I want to look at just those ones, right? So I'm going to do where provider, matches PowerShell, right? So I only want to focus on these ones, right? And let's just say as a first one, I'm going to go, okay, provider. Okay, so I don't have, otherwise I'll get all the rows, right? And now if I do that, it's just going to go through, filter out, just show me those fields, right? But I want to just say, so what you're looking is look for unique invocations, because it's obviously doing the same thing a lot, right? So now I want to split that out, right? So it's going to go event data dot script block text, right? As text whatever, right? So now I've built a new table, because this is the VQL, right? So I built a new query, and it's got a new table with just the script, right? So now I can go, okay, well let's see how many times did you use the same thing, right? All of them the same, because this is just something I was testing with. But like you are absolutely right. In this example, because in the production, you'll see PowerShell run, but most of the time it's the same thing, because it would be like a script running over and over and over. And so when you're seeing your PowerShell block logging, it's just the same thing, but you want to group on that, you want to stack on that, so you want to look at the different things. Yeah, so this is exactly right. Yeah, it's a good point.
And I assume you can do invert that filter, so you can say not that filter.
Yeah. I mean you can do whatever. Yeah. But you don't need to, because so this is the thing. The stacking is a GUI feature, so it operates on the data that's already in there. But it's part of the GUI, and so you can do it both ways. So in the past, we used to have to use VQL to do stacking, but it's actually really inconvenient because most of the time what we want to do is so we can do a group by and then group it, but then you want to okay, well now tell me all the things in that group, and then in that group, so then we have to add where we do this, and then where it's that, and then we have to exclude the things like you're saying, right? So in VQL, so you can always do that the old way. And it's more powerful and definitely, better. But this is quicker because it's in the GUI, right? So I just find that since this feature arrived, I'm using it all the time. It's really awesome. So it's actually pretty cool. So Evtx Hunter. So that was really cool, right? So we went through, and we basically, did that. We found some interesting stuff, and I really love the Evtx Hunter it's like going fishing, because you're I have no idea what I'm going to find, but it's always going to be really cool. And so that is a really good technique to use when you don't know what you're looking for, right? But how do you scale that up, right? So in this case, there might be a number of event logs, and there might be all kinds of bad things that are happening on this machine, right? But we don't know, but how, so you might say, okay, we've seen, for example, that sysinternals rule, remember with the registry hunter that says that EULA was accepted, and remember how I said, if your legal person has that on there, there's no reason they would run PSExec, this is a red flag on their machine. So that's really bad. So you might say, okay, well, let me go and look for this flag on that on that machine, right? But there's so many little flags, so many little things to look for. What if you miss one? What if you you don't know about some, right? You can't look at everything. You can't look at, and you can't just manually start searching for every single thing. It just doesn't scale. What we really want is a way of encoding all of these badness, all these things that are potentially bad. We want to encode them in some rules that tell us these are bad, and just look at them in one like shotgun approach. Boom, right? Get all the data. And so this is where Sigma and detection comes in. That's really detection engineering, right? Like that's how we do detection. Detection is all about finding what's bad on the system. And we did it manually, but we need to automate it. So let me just show you quickly. I'm not going to go into too much detail about Sigma because my talk is on that on Friday. So I invite you all to please come to my talk. So someone will be there. And then we will talk about Sigma in more details. It's Friday afternoon. I think it's the last session. Maybe everybody will be gone. But here's an example of a Sigma rule. And the idea is to try and kind of codify what's bad about this. So here's an example of what it looks like. So it's basically saying, this is a PSExec lateral movement. So it's saying, have a look at the system event log, right? And for event ID 7045, which is a service creation event, if the service has the word PSExec in it, like that's bad, right? And also if the path or the binary name has the word PSExec in it, that's also bad, right? Like someone's running PSExec, right? Now, it's not going to catch those good operators that rename it and rename the service. It's not going to catch those, right? But that's not what it's for. It's not a firewall. It's not like saying, I'm going to stop all badness. It's not about that. It's about saying, if you do this, you will get trapped. You can sidestep the trap, right? But I'm going to lay all these traps around, and then, that's detection. I'll detect it if you do this. Of course, good operators, they have better ops than that, right? But it helps, right? At least those script kiddies, will fall in, right? So anyway, the point of it is to say, I've now codified what's bad. If I see this, that's bad, right? That's the goal. So imagine I have like hundreds of rules like this, thousands of rules like this, all the bad, right? And then I'm going to basically run that on the endpoint and try and figure out what is bad about this endpoint. And that's really what triage is. Triage is, I'm going to triage all my systems and see which one's bad. I just want one little, clue. It's not exhaustive, and I'm not going to find everything. It's just telling me which one. It's triage, right? So this is the point. Normally, you run Sigma on the SIEM, but we can actually run Sigma on the endpoint directly. And in that case, we are actually looking at the event logs that are actually the event log files that are on the endpoint. So we don't need to forward the events first, right? We already have them. They are on the endpoint. Yes, it's only going to look at the ones that are there that probably before they got rotated, they could be like 2 weeks old, whatever, right? But it's something. And so what we are doing is we are hitting up all of these Sigma rules, and only the things that we think are bad, so the detections, they are going to be sent to the Velociraptor server. So instead of sending gigabytes of log files, we are already kind of filtering them on the endpoint. And we're only sending the things that are bad. Okay, so it's actually very easy to do. Again, it's one of those Uber artifacts that you just don't even need to think about. So let's do that. So again, the same kind of thing, we have to import it from the Sigma side. So let's run the server artifact to import the curated Sigma. Yep. So go like there. And there's a couple of different ones actually. We've got Chop Go, which is the Linux one. We have some Hayabusa ones, and then we've got some other ones, but this is the one that would normally import. So again, this just brings the artifact in. It doesn't really do anything more. And now we can use it. So we're going to collect that artifact, and it's got Sigma rules that are curated. So someone had looked at them. So they should be more or less okay, but they're classified according to levels. And so I'll just show you in the artifact. So we have the rule level and the state of the rule. So whether it's stable or whatever. And so these are, because you got to remember that sigma is used for detection. And so you don't want, like say, it's always like a false positive versus false negative type thing. So generally they have rules that are really strong, rules that are weaker, or whatever. But because we're doing this triage, we don't care if we have a lot of false positives. I can deal with that. It doesn't matter. I just want to know everything, right? So I'm going to go like, okay, just give me everything, right? Just give me everything. And then in here, I'm going to go all rules. Just do it all, right? And so that's going to pull in a lot of rules and a lot of logs. It's going to take actually a long time. But anyway, let's go for it. And so what this is doing is it's pushing all of the rules over to the endpoint, right? And then the endpoint is going to start working. I'll just show you the log. So this is the query log, right? And you can see that straight away it's saying, I'm loading 4,000 rules, okay, into 34 log sources. So a log source is like a file, like a log file, right? And then it's saying, I'm going to start drawing events from these log files and then running the rules on them so that it's like a big filter, right? Like filtering those event logs to try and find detections, right? According to these rules. So what it does is it splits off the rules according to the, to the log files, and then it runs through, passes them all up. So it says like in this case, it's got 582 messages on 8 rules. So it's got 8 rules that apply to this particular log file. What is it? AppX deployments, or whatever it is. I don't know. So different ones, right? And so so you have like OpenSSH, for instance. There's one rule that applies on that, but there's no events. So it basically goes through and it just pulls off events. And so as it's doing that, it's sending us the detections. So when a rule matches, right? So it's a detection. And so we can see here, we've got the detections coming through, right? So we have the title, and then the details is just extra information that it's basically telling us about that it's being detected, right? Right, so we've got, so there's a couple of, we're going to talk about this in the talk on Friday. Yes, go ahead, sorry.
That's the question that came to mind with this one and the previous ones when we went to the server. How do you run one of these collections again? So how can you go today?
How do you run it again?
Yes.
You just copy and paste it.
All right, so there's no rerun.
You just go like this, copy and paste.
Okay.
Yeah, just copy and just do it again. Launch it. Yeah, so this is the collection that's a point-in-time collection.
Yes.
Yeah. So you do it once. Now, for Sigma, we also have live collection for event monitoring. And what we do there is we basically get all of the rule sets, like 4,000 rules that we're talking about, and we basically monitor the event logs as they're written, right? So we check them every 30 seconds or so for new events. And then we run the new events through the rule sets. So it's actually pretty cheap. We don't. So that's an expensive operation because we are just like hammering all of the logs, through it. But when you do it in real time, you're only looking at the last 30 seconds.
But you still have to want to download those new rules with rule updates.
Yeah, no, but the server does that automatically. So when you update the Sigma, over here we went to the server. So for the monitoring thing, there's a different artifact. I'll show you. So here.
Okay, so this is the monitoring stuff.
Yeah, for the monitoring stuff. So if we remember here when we curated, and then we chose to import the artifact. Remember how I showed you there was a number of different selections here. So this is the default, but there is also a live detection version. So that is a different artifact that's to do with live detection. So when I import that live detection, if that is deployed, it's out of scope for this workshop because we're not doing live detection, but if it's deployed, then it will refresh that rule set on the endpoint. So so anyway, it's going off and it's going to take, I think, about 5 or 6 minutes. But anyway, let's show you quickly how to do the stacking. So again, I'm going to be in the notebook here. I'm going to go full screen because it's just easier, and I'm going to remove that limit. Okay, and save. Okay, so I'm going to have, I don't know how many, 70,000 rules. So there's a lot of hits because I chose the really noisy rules, right? Like I chose all the rules. So, if I go back, just go to the bottom here, there's like 40,000. It's not finished yet, but I'll show you before it's finished. So there's a lot of rules, right? But what I actually want to know is what type of activity is going on this endpoint. Because remember that if it's a really noisy rule, it will fire every time something happens, right? So I can have the same rule firing lots of times, but I don't care. I just want to know like what kind of things are happening, right? So what I would do here is I would start to stack by the rules, because I want to know like what type of rules are firing on this endpoint. So I will sort by the title of the rule, right? And that's going to take a little while. Come on, go. And then I can start to stack on that. So it's doing the stacking at the same time that it's doing the sorting, right? So it's, yeah. All right, so then I can stack it, and these are all the different rules, right? So if I sort them, then I can see like this DNS query rule, it's firing lots, right? Because actually that rule, it doesn't even say anything. It just says this DNS lookup happened. It's like DNS happens all the time. It's not really bad. So that is a really, really noisy rule. Then we're going through down and, okay, we've got file created, sysmonolith, still noisy, don't care, right? And so basically we go through those rules, and then suddenly, like time stomping, that's such a weak rule, not really interesting. But then as we get down the thing, then I can start to say, ooh, admin user remote logon. That's interesting. That's more interesting, right? On some machines it would be more interesting. In this one, not so interesting because admin user is always logging on because that's the only user. Proc terminal, etc., etc. So we go down the line. RDS session start, RDS logon, right? And then we can start to investigate. Okay, so we've got that's a remote desktop session, right? So we got remote desktop session. Someone logged into it. So now we are starting to get this idea, right? Like, okay, so these are rules that are essentially very noisy, but it gives us a good idea of what's happening on this endpoint, right? So we know that there's RDS sessions happening, and so on. So this is a really good example of just how to use it. A service crashed. Here we go. So there's a service crash. That's usually a bad sign. Yeah. No idea. So it basically goes through. So that's how we can use Sigma to basically give us a really quick overview of what happened on this endpoint from a forensic point of view. All right. So we've gone through that. We're stacking. We're viewing. Okay, and that was kind of the end of the thing. So we actually we got another half an hour, right? And we've got 2 more topics, which I don't think we could do both, so we're kind of out of time again. But we could do the process tracker, or we can do NTFS analysis. Which one do you guys want to look at? Process? Awesome. Okay, let's do a process tracker. So again, a lot of this, there's so much in there that you can't really cover everything. So I just kind of chose some topics in random. All right, so let's talk about the process tracker. So any feedback about the Sigma stuff? You guys find it useful or? Yeah? Cool. It's really just all about trying to quickly triage things.
Is that something, if the Sigma's happening on the endpoints, is that something you put in the agent and push them out, or is it something that they will pick up when you need to?
So it's a supported part of. So as I said, Velociraptor is a VQL engine, right? And so as we develop it more, and so we are adding more functionality into the endpoint and exposing it via a VQL plugins or functions. And so your queries can access more features, right? And so of course, as more features are added, you got upgrades, so you get those features, right? So it's a two-way thing. So this is what I said earlier on, is that we try and do all the complicated things, like the really hard stuff, like the Sigma engine is a whole engine, it's quite complex, right? So it's a VQL plugin, and then your VQL goes in and kind of uses it, right? Like you say, hey, use these rules, use these log sources, and it uses it. But again, it's so it is actually built into the agent. We're not really shelling out. But there is another one called Hayabusa, which is its own tool, and you can use that as well in a similar way. And it's a really, really good project. And of course, we use all of the rules as well. So they are actually like really, really awesome. And you can use that if you have an older client. And that Hayabusa one is actually Hayabusa. It's actually on the Artifact Exchange. It should be. I think we imported it, right? Hayabusa. I don't know. And so you can actually. So it brings their tool. It's a different tool. It's written in Rust, and it basically downloads their tool onto the endpoint and runs it. And it does a similar thing as well. Yep. Okay. Where was I? Okay. So Process Tracker. So. Process Tracker has been around for maybe a year or two already, so it's not super new, but it's actually a pretty cool, feature, and we use it a lot. And it's actually kind of interesting because Velociraptor started off as being a forensic tool, right? Like look at Registry, look at NTFS, look at different things, and a lot of that, and at that stage, I was like thinking, well, when we do forensic investigation of the endpoints, like we have to be lucky, like let's face it, right? A lot of the forensic evidence that we rely on every day is just there by luck, right? If Microsoft changes the feature, suddenly the prefetch that we rely on, it's gone, or the, whatever, L&K analysis or registry analysis, all of these things are so fundamentally fragile that we are relying on things that weren't really designed for that, like the Windows search index. And so we always get this feature, this forensic artifact, it used to work until Windows whatever version, and then it stopped working until Windows whatever version, or it meant something completely different. So a lot of the time what we're doing is kind of lucky accidents and side effect, right? And so when we don't have any control on the endpoint, then we kind of have to live with what we have to live with. Like it's not ideal, and we have to make do. But we actually have an endpoint agent running on the endpoint, right? So we have Velociraptor running there, right? So why not take advantage of that and get a better picture? Like what if, this is what I was thinking, like what if I was working for Microsoft and I said, hey, my goal in life is to make the life of the forensic investigator better. How would I do that? That's literally what I was thinking. Like, how would I make their life easier? Well, the first thing I would do is just record, everything. Every time a process executes, I want to know about it. Every time, a registry key is written, I'm going to know about it. That kind of thing, right? So instead of then trying to understand, process execution through side effects, like, oh, there's a prefetch or whatever, I will actually do it, record it. So that was the idea of these tracking processes. Like, the main question that we're doing in forensics is, there's this process running on this machine. How did it get there? Where did it come from, right? So we have so many forensic artifacts like prefetch and app compat cache and all these things that tell us about a process ran on this machine. why? How did it get there? Where did it come from? Sometimes we don't know that. We just know it ran, or we don't even know if it ran a lot of the time. So we don't have enough context and we don't have enough information. So yeah, we could record process execution from everything. There's going to be like tons of logs. What are we going to do with it? How do we ship them? So we've got that EDR solutions, kind of already there. But it's kind of heavy-handed. And sometimes we don't really necessarily know which process is interesting, so we have to keep everything just in case. So anyway, I got to thinking, well, what about if we just remembered all the processes that are running on the system, just remembered. And so then if something happened, what if we asked Velociraptor, hey, this process, where did it come from? And then we can tell it. So we can know that because we asked about it, then we saw this process is relevant to something. So we can report that information. But generally we won't report the information, just remember it and deal with that. And so we can actually do that, and then we can actually get information even if the process exited. And so we don't really look at the information at the system state. We look at what we know about the system. So there's a very subtle difference there, but it's actually quite a strong one. So let's do this exercise and see how we can enable the process tracker. Oh, okay. So in this case, the process tracker is a part of Velociraptor that tracks processes, right? So it has to do it in real time, and it's part of the monitoring, which we didn't really touch on in this workshop, but essentially it's a monitoring artifact, right? So it's basically VQL that's pushed to the endpoint, and it's saying monitor for processes, right? So we go into this part, client events, and then we click on this little thing to update the client monitoring table, and we can select different groups, but in this case we're going to choose the old group, let's say, just for this example, and then let's choose the process tracker. So it's actually pretty easy to configure because we just need to turn it on. So it's not on by default. So we've got track processes. There's a couple of versions of this. So this one uses sysmon to get process execution logs, essentially, live feed from sysmon. And that's the best one if we can do that, right? But sometimes people don't like to install sysmon. So then you can use this one, which is the basic one. And it's not as good because the way it knows about processes is it just does a PS list every few seconds, and then it figures out like, oh, a process is gone. So so it figures out it terminated. So it gets that information, but it's not so good because if a process started and stopped really quickly, you're going to miss it. So it's not as good. So we're going to turn on this one, which is the sysmon one, and so it's going to need to install sysmon, and it's going to do that by itself, so you don't need to worry about it. And this is the VQL. We don't really care about it that much. So anyway, we just launch it. It's going to fetch sysmon. It's going to push it out to the endpoint. It's going to install it. It's going to run. Right. So that's part of that. And so you can actually see the log. If you look at the logs, there's a query logs on those things as well. And it will tell you, okay, I'm going to get sysmon, I'm going to install it, going to fetch it. It runs an external program, so that says sysmon install yourself kind of thing. Where is it? And anyway, it's installing itself. So now, hopefully, this does it say anymore? Yeah, all kinds of stuff. So it's added the provider. And it starts. This means that it basically starts to watch sysmon. This is the provider for sysmon. So it's saying I'm going to start watching that log. It's actually using ETW, but anyway, it's similar. So it's getting process execution events, and now it knows about processes, right? So it says, so I know that this starts that and whatever. So now we're going to emulate a typical attack. Okay, so let's do that. I'm going to start up a shell. Here's my shell, and I'm going to use psexec. I'm going to run a typical attack, so I'm just going to put it like on this side. I actually have psexec here, bin2 psexec. Okay, and /s means I'm going to run a system shell, but this is like emulating lateral movement, you know. But anyway, it's just for the demonstration. Now, what we do is we're going to run PowerShell, right? So this would normally be run remotely across the network. So now this is a system shell for PowerShell, right? And then I will do like some stuff because I'm like an attacker. I'm going to ping something, maybe Google. Okay, so ping whatever, and then I'm going to curl something, curl -o, you know, script .ps1. That's going to be my https google.com. That'll be my like watering hole or whatever. I'm going to, you know, grab some stuff. Then I might run Notepad, maybe. Okay, it's actually running in a different, so we can't see it, but it's there. And then I might, okay, I'm done. I owned you. Exit. Okay, so this is like a typical, you know, sequence. But now, what would happen if we try to see what's happening? So let's say if we run, let's say bin2 process explorer, proc explorer. Yep. So you guys know Process Explorer. It's a really cool tool because you can see, here it is. You can see all about processes and, you know, and parents, child. It's just a GUI, but it's quite useful. It's a really good tool. And, you know, so we will see, where is Notepad? I can search for, find Notepad. Notepad. Oh no, this is the wrong one. Searching the DLLs. Oh, come on. There's got to be a Notepad here somewhere.
What was the Notepad in with Chrome down the bottom?
Down the bottom? Oh yeah, here. So Notepad. Yeah, that's it. Sorry. So yeah, so we see like Notepad is like our suspicious process. This could be Cobalt Strike or whatever. It's probably Cobalt Strike, right? But anyway, just for this demonstration, pretend this Notepad is Cobalt Strike. So I go to this endpoint and I'm like, there is something on this endpoint. There's Cobalt Strike. How did it get there? And this is where we find ourselves in forensics all the time. We are like, Cobalt Strike is running on this endpoint. Why? How did it get there? Where did it come from? And so, you know, if you look at that and look at the properties, so most of the tools like, you know, are like Process Explorer. We're looking at it and we're like, yeah, you know, we can see it, you know, whatever. But, you know, we can look at the image, you know, but where does it show me the parent? Here, the parent, and it says, well, I know the parent ID is like 1592. But I have no idea what it is. Don't know, right? Because the API, like it's querying the process and it says, oh, that's your parent. But like, I have no context. I don't know what I don't know where this thing came from. And that's the problem, right? So in forensics, we don't know that. But if we are able to do like process tracking, then we could see that because we saw that process start, right? And so we know where it came from. We just remember that. So we don't need to query the API for that. And that's really what the process tracker is all about. It's tracking processes, right? So let's see how we use Velociraptor. So I just demonstrated this thing. Yep. And what we're going to do is just do a very simple PS tree. Okay, so I'm going to go over here on my endpoint, and I'm just going to collect a PS tree. PS tree is like a process tree. So it's just like what we saw before, but PS tree, parent, child. But you can see that if you look at the VQL, it's using the process tracker to actually query for the tree. So if we just, oh, sorry, I should have actually got the tree. If we configure the parameters, then we have to include the tree visualization. Anyway, you'll see it. So off we go. So it's 155 processes. It's on this endpoint. That's not too bad. And now there's okay. So we've got the process tree here, and you can see that Notepad, call chain, filter, Notepad. Actually, let's close some of these things. PS3 call chain. So I'm just going to hide a few of those things. All right. So if I'm filtering for anything to do with Notepad. Okay, great. So I can see there's. So look what it's showing me straight away. I can see this Notepad. It came from PowerShell, okay, and from PSExec service PowerShell Notepad. This looks really bad straight away, right? Whereas, so how does it know that? It knows that because it saw the processes as it went along, right? But it didn't. If I just do the API calls, I'm not going to see that. But because I tracked it, then I can see this extra context. So let's do something else. I'm like, oh, okay. So this PSExec. That's actually pretty cool, very interesting. So let's filter by PSExec now. Okay, so I'm just going to filter by that, and over here I'm going to look at the visualization for the process tree, of PSExec. So now what I'm seeing here is I'm seeing PSExec started, right, and then you see how I've got an end time here? That's telling me that it's finished. It's not running now, right? This is coming from the tracker. It's saying, I know this ran from that point to that point, right? But now I can go through and say, oh, okay, well, I can see that this PowerShell was spawned from that PSExec, and then they did this, and then they did this, and then they did this, right? So I actually can tell what the attacker has done, like what they did on the system. First they ran ping, and then they did something else, and then they ran Notepad. But all of these processes, because I've got the termination, the end time, that's telling me that these are terminated, right? But the Notepad is still running. So you see, I don't have an end time. It's 0. Yeah. So the Notepad is still running. Everything else is gone. So this is an example of where we're trying, because of the Velociraptor doesn't have it doesn't really need to resort to forensics here, because we have better monitoring and better and that's kind of the point of this feature is to try and build in better capabilities into endpoints that are more than just forensics. All right, so yeah, we did that. Oh, and then we're doing NTFS. I don't know, we've got like 15 minutes. Maybe we can fly through it. You guys want to do that or break early? Yeah, we can do that real quick? Okay, cool. So NTFS, this one is actually going to be like, it's actually pretty quick. So let's get to it. So NTFS is part of Windows, you guys know that. It's a really important part of Windows, and we have a lot of capabilities to forensically analyze NTFS. The nice thing about it is it has this thing called a master file table. So basically every file on the system is in this table, which is like another file, right? So we can parse it. What it means is that we can actually parse that MFT and get all the files on the system very quickly, all the metadata, even if that deallocated or unallocated or whatever. We can still get sometimes we can get information about it. And so this is the details. There's lots of I'm not going to get into the details of NTFS here, but what I'm going to show you is that we can use NTFS analysis sometimes to get context that we just cannot get, in other cases, right? And there's a bunch of plugins here that expose the NTFS parser to VQL. So in VQL, we can actually do a lot of logic and essentially leverage this VFS parser. So the first example is finding a suspicious file. We have this thing called the NTFS MFT parser, and that basically goes through and looks at every single file in the MFT and tries to, find information about it. So we can do things like look for file names, look for timestamps, these kind of things. I'm not going to really talk about the file search one, but this is the artifact, and we're going to use it in a minute, but this is just like the introduction for it. And you can see that it has a number of really cool controls. This is probably the second most go-to artifact after the file finder. So then we use the NTFS one in a lot of cases, because it actually covers the entire drive. So this is much faster than a globe over the entire file, because they're all in the same place, so we can actually quickly search the MFT. So if you have a question like, give me all the files on the drive that are called, malware.doc, this is the really good way, because we're going to basically find very few and anywhere. All right, so we have some exercise here, and I'm just going to copy that. You guys can do that maybe at home, but because I don't know if you have a lot of time. But I'm just going to copy that, and it's supposed this script is emulating. I'm just going to PowerShell. Okay, copy that. Yeah, I'm just going to let this go. So what this script does, let me just explain to you. So it goes off, it downloads some malware. Usually the ransomware groups, they might use not necessarily always malware, but they might use these questionable sysinternal tools, right? And they might use them operationally. So we have psexec, which we've already talked about, procdump, which dumps processes, and usually they'll try and dump LSAS or something like that. And then we have secure delete. So that's how they clean up after themselves. So it goes off, downloads the things, and it basically, and this one emulates them downloading it with a browser. If you download something with a browser, it has the zone identifier, which tells you where, where it came from. So this just emulates that. And then the second part of this script is, let's do that again. I'll just get it to go. And then explain what that second part does. And you see what it does is it creates some PowerShell, which is usually their malware stuff. They'll create that, and it's staging it in cperf logs, which is a common place for attackers to try and hide, because no one ever looks there, and it's usually not really relevant. So they try and kind of put all this stuff there, so you can't find it. This is another example where they set the short name. So the short name on NTFS, how you can access a file by short name ~1.exe, the short name. It doesn't have to have a ~1, ~2, that's just a convention. So you can actually set the short name to anything you want. And this command basically sets psexec the short name to fake.exe, and then you can call it as fake.exe, and it will still find it, because it points to the same file. It's just another name for it. So it doesn't have to be at all related. And then it creates calc, which is a Windows thing, and then it dumps the process. So that's supposed to emulate LSAS dump, so you've got some dumps, and and then it exfils it and removes it. So that's just the script of the kind of attack emulation script, kind of, So how would we investigate that? So the first thing we would do is try and figure out, like, let's say that, for the sake of argument, let's say that we know that they're operating out of the perflog directory, so we don't have to search the entire disk, so we can be fairly targeted. So what we're going to do is we're basically going to go with the MFT scan, and we're going to say, okay, look at all the MFT4 files. So this one, again, a very popular artifact, and we're going to basically just kind of look for anything in the perflog. Right, so we're going to search here with the path perf log. Okay, so that just filters out anything on the perflog directory, and we launch that. Actually, what happened here? That didn't take long enough. Oh, I think I messed up. Sorry. Try it again. What have I done here? I put it in the wrong place. Let's try it again. Yeah, sorry, the path regex perflog. So anywhere in the path where it matches perflog, then so this is basically going to scan the MFT, like every single file on the MFT, and then just pull out information related to that. While this is going, I'm going to also use, just to save time because we don't have time, so I'll just get the other one to go at the same time. The USN log, which we haven't really talked about, but basically it's telling us about file changes. So the same thing I'm going to do for that. Just tell me anything to do with the perflog. Path regex perf log.
Is that Windows Forensics USN?
Yep. That's right. So we're just going to do it at the same time because we don't have time, so we'll just do it together. Yeah, so this takes like a couple of minutes. And so basically what this is going to do is the USN log is a log of every time a file was modified. And it's just kind of like written on the, I think I've got a few slides on it, so we'll just, yeah, like over here. So it's just a forensic artifact. It's a sparse file on the NTFS volume, and every time Windows changes a file or does something to do with the file, it writes a record on the end here, and then and then it just keeps kind of like growing that way, and then the sparse part just kind of like eats into it this way. So it's actually only about 30 megs or so, but it reports itself as being massive because it doesn't really contain any data, right? There's usually about 30 megs of data in it. Anyway, it's just a forensic artifact. You don't really need to know about it, but the cool thing about it is think about the USN journal as just a log file anytime some file was changed, right? So the cool thing about it is even if the file's deleted, so the file's not there anymore, right? But you've got a log file. It's as if someone's written a log to say, I wrote this file, then I wrote that file. So in a case like this, where you have a ransomware group trying to stage a directory and then exfil, right? So the files are gone, right? Because they deleted them. But you've got a record that they were there because they were written and then they were exfilled and then they were gone, right? So you've got some idea of what happened, so which again helps a little bit. Okay, so we've done this. So if I just show you really quick, so that's the MFT scan, and you can see that we've got the PS exec here, we've got the proc dump, and there's not a lot else here. Okay, these are just obviously self hits again, sdelete, and basically that's that's it, right? There's secure delete, there's zone identifier, and proc dump. So these are the only binaries that are left behind. So there's not really any evidence here to say, did they exfil stuff? What did they get? We don't really know because the files are not there. They're usually not left. But if we look at the USN journal, let me just look at. Okay, let's look at all of it. Yep. And then let's just show a few of those files. Yeah, I think that's probably all we need. So we can see a lot more files. So we can see the PS exec, and actually, let's also add the reason. So the reason tells us like why was the file touched. So here, the USN also records what was the reason that the file was touched. So it's created. So that's the first time that this was created. This is not relevant, but so we know this was created. This PS exec was created on this time, 8 minutes ago. So that was the time of compromise. Really important, right? So because we've got that from the USN log, and that's when it was written and so on. And then as we go along, then we can see some more interesting stuff. So we can see this calc.dump. That was when it was deleted. So we actually know in the log, it's telling us, hey, that file was deleted. So we know when it was deleted, right? And the name suggests, that it was a memory dump, right? So we've got the X field, and then we've got the test.ps1 is deleted, right? So they were deleted at this point. So this is an example of showing you so we have the attack script, which was like emulating a typical ransomware group, and we can use the USN journal and the MFT parser to together get more of a context of what's happened. So that's the NTFS thing. So yeah, just rush through it real quick. But yeah, we basically did it all, right? So what did we not cover? So much. Anyway, so in this workshop, we introduced Velociraptor, we introduced VQL, search for files, learned about stuff. These are all the references. Jump on, open source tool, active community, lots of people use it. It's really great. We're on Discord a lot. It's like a happening place. Ask questions, mailing lists, maybe not so popular, but it's also good. Yeah, so any questions, you can catch up with me later, and yeah, thanks for listening.